The USB standard has been changing a lot since the USB 1.0 in 1996 with 1.5 megabits per second till the USB 4 version 2.0 in 2022 with 80 gigabytes per second. The USB 2.0 started with 500 milliamps current capability. Then the 2 amps chargers for mobiles and cell phones, and lately the USB-C mechanical standard supplying 3 amps or more. USB ports have been used for some time now, more and more, due to its abundance as 5 volts DC generic power supplies. You can find USB ports almost everywhere nowadays. And as you may have noticed in my videos, many of my projects use 5 volts as power input, exactly due to that reason. For example, this 10 MHz GPS-DO, my 18 GHz mini counter, and all these other projects you can see here over my workbench. You can even find commercial equipment using this strategy. For instance, this 30 GHz signal generator over here. So I decided it was time to find a way of providing a few 5 volts source outlets in a compact arrangement, sit on my workbench waiting to be used. You could, for instance, just fix a power board on your workbench and use some phone chargers like this arrangement here. The whole thing seems to be a bit bulky, but the question is, are they suitable to be used with more sophisticated devices? Well, let's measure their behavior under stress and see. And I will measure all these devices here. This is a 1 amp Apple charger. These other two here are 2 amp Samsung chargers. This big one is a generic low-cost 3 amps charger, and this is a USB 3.0 generic hub, 2 amps to be shared with all ports. First of all, let's measure the intrinsic noise of the setup. It's about 2.3, 2.4 millivolts peak to peak. And if I insert the input filter, it drops to about 920 microvolts peak to peak. All my LED lamps are off and the input cable is connected to nothing. The first unit to be measured is this Apple charger, 1 amp. Let's connect the cable. And we have here 25 millivolts peak to peak, and with the input filter about the same. Now let me increase the current to 2 amps. And now let's test this white Samsung here. We have here 68 millivolts peak to peak and 65-66 millivolts with the filter on. Now the black Samsung. $72 millivolts peak to peak and 71 with the filter. Now this USB hub still 2 amps. About 57 millivolts peak to peak, and including the filter it's measuring the same. Let's now test this generic 3 amps charger. Let me increase the current to 3. You see here that there is a massive increase in the noise, and it's measuring now 275 millivolts peak to peak, and if I include the filter, it's about the same. At this point I decided to design and build a set of USB-like 5 volts power supplies to fit inside this plastic enclosure. The power input being about 12 volts. My design, as you can see here, has 6 power outlets, 3 for 1 amp and 3 for 2 amps. I used the LMR51420 buck converter for the 2 amps outputs and the LMR54410 for the 1 amp outputs, both produced by Texas Instruments. The manufacturers normally include the schematics in their data sheets, and Texas is not an exception. I have populated my prototype for 2 outputs, as you can see here. One for 1 amp and the other for 2 amps. And now let's test their performance. Let's start with the 1 amp output. I set 1 amp here, and we can see the noise is about 17 millivolts peak to peak. If I include the filter, it drops to 12 millivolts peak to peak. Now the 2 amp output, increase the current here. Now we have about 21 millivolts peak to peak with the filter and 25 millivolts without the filter.